Hello everyone. So our today's topic is hardwired control unit. So what is control unit? Control unit is basically responsible for generating control signals. A control unit can be implemented basically by two techniques. First one, the hardwired implementation, and second one, the microprogrammed implementation. So we are going to learn about the hardwired control implementation. So hardwired control unit is implemented as sequential logic circuit or finite state machine that generates a specific sequence of control signals.
Hello everybody, the motive of this video is to make you familiar with the hardwired control unit. The diagram in front of you is basically short and simple structure of hardwired control unit. Arrow in the diagram represent working of respective devices which are connected to our control unit. First of all, instruction is fetched from the instruction register, that is IR, to the logic circuit. The status arrow check whether our unit is ready to accept the instruction or not and send signal through respective devices. The logic circuit decodes the instruction and send output in the form of control signals. And at last, at the bottom left, arrow of clock indicates device which manage time of instruction or order of the next instruction that is to be decoded.
Control timing signals. We have an instruction register which is of 16 bits, of which first 12 bits means from 0 to 11 are there for storing the address of the operand, means the value on which the operations are going to be executed. Then from bit number 12 to bit number 14 specifies the opcode, means it indicates which operation to execute. And the last bit, which is the 15th bit, indicates whether it is a direct or indirect addressing mode. As the opcode is stored in 3 bits, means it can take 8 values from 0 to 7. To decode this opcode, we have a decoder which takes 3 bits of the opcode as the input and decodes it and can give 8 different types of output to control logic gate, which further instructs the CPU to perform the operation. System counter, which has 4 bits, is connected to a decoder which can give 2 to the power 4, means 16 outputs from 0 to 15, which are passed to control logic unit. System counter can generate 3 types of signals, which are clock pulse, increment, and clear. When clock pulse is generated, the cycle starts with T0, and when the clock pulse and the increment signals are generated together, the value changes to T1. This increment goes on till there is a clear signal. When clear signal is initiated, the next cycle starts again with T.
The next topic is techniques for hardware control unit. There are four methods. First one is state table method. It is a classical method of sequential design which minimizes hardware. It changes its state according to the instruction and then generate control signals. Basically, we can implement it from final state machine. Every generation of state has a set of control signals. Second is delay element method. In this method, control signals follows a proper sequence. There is a specific time gap between two groups of control signals. To ensure synchronization, D flip-flops are controlled by a common clock signal. Third one is sequence counter method. This is the most popular and most commonly used method for generating delays between every consecutive control signal. And its main advantage is that it uses the logical approach of flowchart and doesn't use the necessary number of DFF. Fourth is programmable logic array method, that is PLA. It is a kind of programmable logic device used to implement combinational logic circuits. The PLA has a set of programmable AND gate planes which links to set of programmable OR gate planes which can then be conditionally.
A new corresponding input for the control signal generator matrix is formed as a result of this. When an external signal such as an interpret comes, the control unit enters the next control state, which is concurrent with the response to the external signal. For example, interpret processing. The computer flags state variable are utilized to choose appropriate states for the cycle of instruction execution. The cycle's last states are control states that begin fetching the program's next instruction, sending the program's counter content to the address of the main memory buffer register and reading instruction word into computer's instruction register. The control unit enters an OS state where it waits for the next user directive. When the running instruction is the stop instruction, which terminates program execution.
Slide we are going to discuss the advantages of hardwired control unit. Hardwired control unit is fast because of the use of the combinational circuit to generate signals. Hardwired control unit is faster than microprogrammed control unit. It depends on number of gates, how much delay can occur in generation of control signals. It can be optimized to produce the fast mode of operations. Disadvantages of hardwired control unit include that it is expensive, it is difficult to test and correct mistakes in the original design. The complexity of the design increases as we require more control signals to be generated. Modification in the control units are very difficult because it requires rearranging of wires in the hardwired circuit.